Hey there, backyard explorers. Mr. T here again on another beautiful day to be outdoors. Hopefully you're getting out there also. Well, today we're going to be talking about our second installment in the Sensational Senses series. Say that 10 times fast. Today we're going to be focusing on our sense of sight, and we'll be discussing about color in nature. And we're going to discuss how animals, do they see color like we do? Do certain animals see other colors? Why do animals have good sight or not have sight? We're going to be discussing all of these, and we're going to be coming at it from the idea that, again, our senses are an adaptation. And that means that we have these senses, like sight, and the kind of sight that we have, depending on whether or not they help us, number one, find food, number two, not become food, and number three, find a mate and pass on those adaptations to the next generation. Let's go take a look at some of the beauty. So let's have a quick word about our sight and colors in nature, because colors, they evolve with the plants just as our sight evolves for animals. You see, no reason to have bright colors if there's nothing to see them. These plants, they want those flowers to be noticed. So they smell terrific, they look terrific, and they're trying to attract pollinators. Butterflies, beetles, bees, flies, whatever they can. Birds, bats. If there's a way to attract them, they're going to do that because they need them to pollinate them so that these flowers will turn into fruits. And inside those fruits are the seeds. This is a crabapple back here. Beautiful tree. And it wants to make seeds so that it can spread around and, continue on with its own kind of species. So the interesting thing about this, though, is that the colors that you see on these flowers are not the same colors that a pollinator like a bee or a butterfly or a bird are going to see. You see, we see the rainbow, right? The what we call the visible light spectrum. Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. Those are the colors that we can see. Birds, however, and those other pollinators, they see more than that. They're sort of shifted over. They can see an extra color beyond violet that we can see. It's called ultraviolet. And it's a color there, and we just can't see it. Our eyes haven't evolved or adapted to be able to see that. So the really neat thing about this is that a bee or a butterfly might see this flower, and it actually looks like it has landing strips almost pointing them inside the flower, like "Eat at Joe's" signs, saying "Come and get it right here." It wants to attract them by any means possible. So it's kind of neat to think that we don't all see things the same. Maybe an interesting lesson in that. Let's see what else we can find. So one of the other things that we can talk about when it comes to color is, why are some animals so brightly colored and some aren't? Well, once again, let's come back to our adaptation talk. What do you think the reasons could be for having bright colors? So, for instance, when we talk about our brightly colored monarch butterflies, like we have here at the sanctuary, we need to ask ourselves, well, why would they be brightly colored? Because they can't be very ferocious or anything like that at protecting themselves. Wouldn't they want to be camouflaged? Because camouflage is an adaptation to, yeah, you guessed it, number two, not become food. So why would bright colors be a good thing? Would it help them find a mate? Well, in some cases, like with birds, that could be the case. But in the case of the monarch butterfly, the bright colors are actually a warning to the other animals, to the predators. The adaptation is, it's another number two, don't become food. It's a warning to predators because, you see, the butterflies, the caterpillars from the monarch butterflies, they eat milkweed. And we grow all kinds of native milkweeds here to support those butterflies. And those milkweeds are poisonous, but not to the caterpillars, not to the butterflies. So they fill their body up with this poisonous milkweed. And they, instead of getting eaten and getting a predator sick, they warn those predators by saying, hey, look at my bright colors. I don't even have to hide. So if I'm not hiding, there's probably a good reason for it. Now, I'm not saying that those predators like birds and blue jays and things like that are necessarily thinking that, but it does become an instinct that bright colors actually could mean danger. So in this case, bright colors are protection. It's danger. With birds, there's a different reason. So I'm using our big zoom lens over here to try to get you guys some video of the male birds that are just in their full color glory right now. They've got their brightest colors on of the year, and they're trying to impress those females with their bright colors and their beautiful loud songs. And we've got birds like the Baltimore Oriole up in the apple blossoms. There's the red cardinal. There's the bluebirds in their bluebird boxes. And we really need to ask ourselves, though, remember that colors and the senses, they're an adaptation, and we have those three reasons. So we know that the color is, that bright color and the high-pitched song and the loudness and the mating dances that they'll do, that's to attract a mate. But ask yourself, why would the female be interested in something like that? There has to be an actual reason for this. And this is the interesting part. It's not just to stand out among the others, because to be honest with you, these birds, they're not venomous, they're not dangerous, they're not poisonous, so these aren't warning colors like you see on monarch butterflies and venomous snakes and things like that. So why would they have these bright colors? Well, the answer is because the females want to know that the males can best protect the offspring. And the way that the males do this is once they have their nest and they have the eggs, if a predator comes by, the male's job is to draw them away from the nest. So the brighter colored they are and the louder they are and the better they can fly, the more likely they're able to get the attention of the predator and get the predator to chase them away from the nest. Now, this is truly an amazing behavior that they do. So that gets more to that survival adaptation that we had been talking about. So this is really what the female is looking for, is this male, is this the guy who can really, draw the predators away? And kind of a brave mission if you think of it, kind of crazy, but that's how it works. Now, don't leave the females out because they've got their own thing to do. While in most species, the female will sit on top of the nest and they're a little bit more darker or drab colored because they're hiding those eggs. If a predator still comes near and the male isn't there, maybe because he's already chased one predator away or had them follow him, the females will do an acting job since they don't have all those things going for them to attract the predator that the males do. So once they're found out and they think, okay, they're coming for the nest, the female will jump off the nest and she'll play like she's injured. She's an actor. So she'll pretend that she has a broken wing or something like that and will flutter around and jump and drag the wing behind her, making herself look like an easy meal for the predator. And this is truly incredible because as soon as the predator gets close to her, she'll fly off and then start doing it all over again to keep drawing the predator further and further from the nest. So these are these behaviors and the physical parts about them as to why these happy accidents become adaptations and why they look the way they do. Go see what's in your yard and find out what things look like they do.